Hi gents, this is Mr. Holding, and we're just going to quickly analyse the results that we got. Now I've made up some here, so these are completely made up. But what I've done I've gone and I've made up some results for sample A, which we said was the flowing water, and B, which we said was the stagnant water. Okay, so I've gone ahead and done my 5 tests: water temperature, soil temperature, water pH, water salinity, and soil pH. Okay, and now I want to look at these and compare and contrast. So what that means is I want to look for things that are the same or close, and things that are quite different. Okay, so we can look at the water temperature and say there's a fairly significant temperature difference for, even though it's in one relatively close area or close proximity, there's a 6-degree temperature difference in the water. Okay, so the flowing water is 14 degrees, whereas the stagnant water that's been sitting around is 20 degrees. Okay, so it's important to think about why that might be. Do you think it's a measurement error, or do you think that there's, maybe that the stagnant pool is sitting in the sun? It's, there are things going on, lacking oxygen, all that type of stuff, which is increasing the temperature. Or is there some other explanation? But it's important to have a look at them. The same thing to go with the soil temperature. So again, well, in this case, there's even bigger temperature difference: 13 degrees for site A and 21 for site B. So they're very different results. Okay, if we look at the water pH, sample A is very close to neutral. It's slightly basic, but it's pretty much neutral, 7.2, whereas site B is acidic. It's 6.3. It's not hugely acidic, but it's enough to be definitely considered acidic. All right. If we look at the water salinity in the flowing water is low, whereas the stagnant water in site B, the salinity is medium to high. Why might that be? Is it because it's sitting there and absorbing salts out of the ground, and therefore the salinity is going up? Or is there some other thing contributing to it? Is there pollution? What might that be? But what might contribute to the water salinity being medium or high? So it's important to think of these things and have a look at them. There's definitely differences here. And finally, the soil pH. 7.1 for sample A, so very close to neutral, and 6.7 for B, and that's closer to neutral. That's only 0.1 off neutral. That's only 0.3 off neutral. So they're fairly similar, even though this is acidic and this is slightly basic. Okay, so we've had a quick look at that. Now, before I suggest you do that and start to have a look at things and get an idea of your results before you start to look at these discussion questions. Okay, because these relate directly to what you found here. So it says for a pH, if a pH of less than 7 is considered acidic, compare the pH of the water and soil at each site. Use data from the results to support your result. So compare the pH of the water and soil at each site. So we could say sample A has a water pH of 7.2 and a soil pH of 7.1. Both these are quite close to neutral. By contrast, the pH of the water at site B was 6.3 and the pH of the soil was 6.7. These are considered basic, which is different to site A. Whilst they are both closed, it demonstrates that the pH of the two sites are slightly different owing to circumstances. So you might come up with an idea for that. But you've compared them, all right? You've stated the similarities, you've stated the differences, and you've made a statement. Now you can see that there's 3 marks there. So it's asking you to do a bit of work. Okay, so it's not simply a one-line answer. The next one, compare and contrast sampling results from still water and running water. So it specifically says water, okay? So you're comparing the two water, all right? The 2 tests we did for water, 3 tests we did with water, I should say, is the temperature, the pH, and the salinity, all right? So it asks you to talk about the sampling results. So there's 3 things that you need to talk about: the temperature, the pH, and the salinity. Are they the same? Are they different? All right, and use your results. It says, remember to use specific results in your discussion. So make sure you put the results in. What did you find? What was the same? What was different? Were they close? Were they far apart? So for these made up results, you might say that the temperature difference was quite great, where the water pH was moderately different, whereas the soil pH was reasonably close, even though one was slightly basic and one was slightly acidic. Okay? We turn the page over here, identify which tests in this investigation were qualitative. So quality being based on judgment, okay, things like colour, cloudiness, and things like that. And if we have a look at here, these are very specific, quite specific, and then we have to make a judgment here. So qualitative there, which tests were qualitative. Finally, suggest one way that this experiment may be improved. Now this is entirely up to you. Well, there you go, so you can see it. It might turn around and say something along the lines of, it would have been better if we had free lollies because that would have made us more motivated. Obviously, don't use that. But if that was one way to do it, write that in. But then more importantly, justify why having lollies available would make the experiment better, why it would make the results more accurate, why it would eliminate errors, things like that. So you need to be specific, pick something you think could improve, all right, and go forward. So one might be an example of use of equipment. So more practice with the equipment so that students are more familiar and therefore less mistakes are made. So you've identified a way to improve and you've justified why it would improve scientific process. Okay, so hopefully you found this useful. That's how to analyse results and go through the results. I hope you found this useful. Of course, if you've got any questions, feel free to come and see me in class. Thanks, gents.